Hello guys, today I'm just doing a UKMT 2021 paper, yeah? This is it's like a UK Maths Challenge, okay? This is like the senior one, so it's like, I don't know, 12th grade, America, I got no clue. But I'm gonna get straight into this. So basically it's 9-minute paper, but I'll try speedrun it, you get me? So yeah, see how it goes. Here's the instructions. Basically you start with 25 marks, and then you answer a question, you get 4 marks. If you answer and get it wrong, you lose a mark. If you don't answer, nothing happens. But later on in the questions, it like gets progressively harder. But for some reason, the marks are still the same. So I guess yeah, people dodge the last questions, and whoever gets them right gets like bronze, silver, gold. Is okay. Right, question 1. Let me just make this smaller. Okay, it doesn't let me zoom. Cicely had her 21st birthday in 1939. Let me try to zoom in on this. Okay, just keep it like that. 21st birthday 1939. When she have her 100th birthday? Well, if her 21st is 1939, and for 100 you should add 79, which is 2018. So let's see. Sequence formed from a sequence of primes by rounding each to the nearest 10. Begin 0, 0, blah, blah. So basically, each number is basically prime, but it's just being rounded. So 2, 3, 5, 7. This will be 0, 0, 0, 10. Okay, that's how it works. So because I don't know much about primes. How many times a week is 40? We have 31's prime. That's one that's been rounded to 30, I think. No, 29. So 31, 32, 33, 34. We only have to know if it's being rounded to 40, it's either greater than 35 or less than 45, something like that. So 35 is not prime. 36, 37, 38, 39, 40, 41, 42, 43, 44, and that's it. So that's not prime, not prime. 37 is prime, not prime, prime, not prime, prime, not prime. Oh, wait, 41 could be 43. 37 is, no, 39 is not prime. So it's 3 numbers. Okay, so I'll go C. Diagram shows 2 congruent regular pentagons in a triangle. What is the value of x? So literally, remember, all these small questions. The reason I can do them, people do them fast, because there's a trick to it. Like for example, this one is a big like shape, whatever. Just think of it like this. I know already looking at this, I know that I probably have to make like angles up to 360. So if that's x, then because it's isosceles, as it told us, no, but just look at it. See sides are the same. So this is 180 minus 2x, because they add up to 180 in the triangle. I know these are the same, and I know this is x. So those ones, I think angle of the pentagon, it should be 108, 108, if I'm not mistaken. So 216 plus 180 minus 2x plus x, so minus x, 360. I think that's 4. Can't see this right. 406 minus x equals 360, and x should be 36. Yeah. 396 minus 36 is 360. Okay. Number 4. Plus insert k is a solution of the equation. What is the sum of the digits of k? Okay. So they just made this question of really retarded, but I guess if you look at it like this, I think that's a good way to do it. I think that looks pretty nice. K over 12. So if I times k both sides, you get k squared over 12 over 15 equals 20. As in times k in the fraction. So you keep fraction stay the same. So k squared over 15. Now I'm guessing k has to be a square number. So k squared should equal square number. So equals sorry, k squared over 12 equals 20 times 15. It's like 300. And k squared is equal to 3600. So k equals 60. We're not taking the negative value because, I mean, you could still give the same answer. Some of the digits is, well, 6. So D. Oh, you know what? Wait, instead of writing them down, we should circle here. Oh. What did we say for 2C? This was 36. This is 6. Right, 5 minutes, 4 questions, not too bad. Oh. The sum of 4 consecutive primes is itself prime. What is the largest of the 4 primes? So it's saying when you add 4 primes that come after each other, it's also prime. What is the largest of one of the ones that you added? So I can't lie, these are questions I think I just look at different like sums of primes. So this is 1, and this gives 17. Wait. Did I already find the answer? What is the largest? It's 7. Because 7, all these are prime and you add them and it's equal to a prime number. Wait, what if I do like 3 plus 5 plus 7 plus 2, 3, 5, 7, 11? Well, that gives 26. That's not prime. Wait, you know, I'll just go with this answer. I feel like there would be multiple answers because then it would contradict. There's only one correct answer. I've literally found it. Okay, it's fair enough. Okay, it's just a diagram of a circle. 3 points P and R placed on the circumference of a circle with center O. So 3 dots out. It was O. Okay, wait. Let me make it nice. Okay. 3 points P, Q, and R placed on the circle with center O, the arc lengths. So let me maybe do that P. Then the ratio 1 to 2 to 3. So Q is 1. And then we make that 2, and then that's 3. Because, and yeah, that's pretty much it. Sorry, my nose feels mad. Ratio 1 to 2 to 3. In what ratio are the areas of the sectors? So I know that if it's 1 to 2 to 3, then the angles, well, this clearly 180. Then we have, should be 120, then 60. Yeah, 60 plus 120 plus 180 is 360. Yeah, angles add up to it. Again, the areas of them, I don't really care about pi. Okay, I already know pi is going to cancel out because areas pi are squared. If you put them in a ratio, pi disappears. So it's either that, or that. It's not C. So first one is going to be 60 or 360 pi, whatever r is, squared. Also r disappears. So we're just left with numbers. 60 over 360 is 1 over 6. 120 over 360 is 1 over 3. And 180 over 150 is a half. Times 6 on everything. 1 to 2 to 3. So it's B. You see, just think about it analytically. Like, don't... Because obviously you want time for the longer questions. Which of these numbers is the largest? So... I can make them all to power of 1,000 because just using normal rules. Keep repeating this process, so we just have to compare the inside part. So 2 to the power 5, okay, I'll just look at it. 2 to the power 5 is 32, 3 to the power 4 is 81, 4 to the power 3 is 64, 5 squared is 25, and then 6. So clearly it's B. What is the area of the region inside the quadrilateral? Okay, so let's give us this shape. 3, 4, 12, 13, 12. Well, clearly this is 5. Using 3 squared plus 4 squared is 5 squared. I think they probably want to use this. Area of the whole triangle. So the area of the triangle minus the area of the inner triangle equals what we want, the area of the quadrilateral. So area of the triangle is 12 times 5 over 2, which is 30. So I already know my answer is less than 30, so all those are gone. It's just A or B. I would guess it's maybe 24, but let's work out. Then 3 times 4 is 12 over 2 is 6. So that's the area of the triangle, and it's 24. And just like I said. So let's be, I should keep against circle marks. And this one was that, right? Wait, 5, 6. 6B. Right. 7B. Okay. Oh, 10 minutes for 10 more questions. Not bad. Okay, number 9. So I need to move this around. Okay. Move the face camera around. Alison has a set of 10 fridge magnets showing the intervals from 0 to 9. In how many different ways can she split the set into 5 pairs so that the sum of... So she's got a set of 10 fridge magnets from 0 to 9 because 0 is included. How many different ways can she split the set into 5 pairs so the sum of each pair is a multiple? Oh, so it means like, well, you have 9 plus 1, right? 2 plus 3, 4 plus 1, 5 plus 0, 6 plus, no, can't do that. Is that it? Wait, how many ways can you split the into 5 pairs? So some of each pair is a multiple of 5. It should be... I'm just going to go with 4. See what happens. I'm not good at these type of questions. It's hard understanding them. How many different ways can she split the set into 5 pairs? So we want 5 pairs from those. So the sum of each pair is a multiple of 5. Yeah, I'll just go with D. See what happens. I think I will check my answers afterwards. Okay. The survey people asked to name their favorite fruit pie. Pie shot shows the outcome. Shows the outcome. Angles shown are exact when rounding. What's the most on people can be in survey? So I'm guessing. Think of the angles as sort of percentages of like the total number of people. So for example, like 140 over 360, because that's the angle. You want that to be. Wait, let me just check. This is 14 over 36 or 7 over 18. So this means that if you times this by a number of population, it should give you 7. Well, not 7, but whole number. That means the answer should be a multiple of 18. So this cancels out that 18 times 5 is 18. So these are still good. Keep repeating the process. 72 over 360. What was that? 1 over 5? 1 over 5. That still checks out. Maybe look at the 40 over 360. 1 over 9. Now C is not an answer. We just check 1 or 8 over 360. Now this is a bit of a dodgy one. Divide by 2, 54 over 180. Divide by 2, 27 over 90. Divide by 3 is 9 over 30. Divide by 3 again, 10 over 3. Is that right? 3 over 10, also a multiple of 10. So answer should be 90. Go with 90. Because 180 is not the smallest number of people. 90, these are all factors of 90. So, wait, what's 18 times 5? It's 180. Never mind. Because 90 is not multiple 18. Okay. Alita claims that if P is an odd prime, then P squared minus 2 is also an odd prime. Which are following values of P as counterexample to example. Well, put 3 in, you get 7. Put 5 in, you get 23. Put 7 in, 7 squared is 49, is 47. 9 squared, 81, 79. 11 squared, 121, 119. 7 I know is, that's an example. 47 is prime. I can't think of any numbers that could go into it. Not 19. Yeah, that's prime. 79 is prime, so 119. Oh wait, 70 plus 4. That's multiple of 7. Okay, so it's E. So I keep forgetting to start these answers. Oh, this one's 4. Okay. Okay, these do get progressively harder, so you'll probably notice when you watch this video. How many positive integers n is remaining 6? Oh yeah, by the way guys, yeah, I'm not like them people that look at the questions first and then answer them. Like, I should go straight for it, okay? So you get to see the raw thinking process, and this is how you should be thinking. How many positive integers n is remainder 6? Wait, for how many positive integers n is remainder 6 when 111 is divided by n? So that means when n divided by 111 is equal... Wait, sorry, my brain's not braining. How many positive integers n is remainder 6 when 111 is divided by n? So 111 divided by n gives a remainder of 6. So let's see how many times 6 goes into it. 120. Wait, I need to think about this. For how many positive integers n is remainder 6 when 111 is divided? Well, if we I think we need to look at like how many times the number goes into it, and then you want the remainder to be 6. So if we divide it, like for example, how many times? So 111 minus 6 equals to 105. So 105 and 111 plus 6 equals 117. 117 looks prime to me. Or is it 117 divided by 3? So I'm just trying to understand. 3 times 2. Okay, 39. 39, 3. 13, 3. 13 is prime. So that's 1, that's 2. So this basically means that... Oh wait, no, it can't be... It is divided, it can't be 117, okay. But basically what it's saying is that you want a number that's a multiple of 105 then, and then obviously for 111 divided by a number, you got a remainder of 6, because 105 plus 6 would give you 111. So I think it can't be 117, my bad. So 105, basically need all the factors, 5, 21, 7, and 3. But also, you got 1 and 105. 1, 2, 3, 4, 5. Is it 1? Yeah, it should work. Oh wait, no, if you divide by 1, then there's no... Okay, that doesn't work. So we have 7, 3, and 5 should be C. I'm just going to go with that at the time limit. Okay, you know what, there's like an hour 12, never mind. But to be fair, there are questions. Let's BuzzFeed. Which of these is the mean of the other 4? So we have root 2. Let's get them in terms of root 2. I think it's inviting us to do that. 3 root 2, 10 root 2, 4 root 2, and 2 root 2. So I can't lie, root 2 doesn't even matter anymore. So it's just 1, 3, 10, 4, 2. So it's saying which of these is the mean of the other 4. So let's do 4 plus 10 is 14, 17, 18. Divide by 4, we don't get it. 2 plus 4. 4 plus 10, 14, 17, 18. Wait, am I correct or is 4 root 2 and 2 root 2? 10 root 2, 3 root 2. Okay. 1 plus 4 plus 2 is 17 by 4, no. I'm pretty sure it has to be multiple of 16. Am I right? 10 plus 4 plus 3, 17. I have no clue for this one. Which of these is the mean of the 4? What? 2 plus 4 is 6. Plus 3 is 9, 10. That doesn't work. 3 plus 10 plus 2 plus 1. 3 plus 10 plus 2 plus 1 is 16. Divided by 4 is 4. Okay. It's D. So I should probably look at the possibilities. What am I doing? What is the smallest number of rectangles, each measuring 2 centimeters by 3 centimeters? Oh my days, I keep forgetting to. Well, the first one was like 3 D. Smallest number of rectangles, each measuring. So you have a 2 by 3, which are needed to fit together wherever overlap to form a rectangle whose sides are on the ratio of 5 to 4. So basically, it's telling us you basically add these, and you get a ratio of 5 to 4, and saying how many rectangles. So then it would be, the area of it would be the answer, because that's how many rectangles are. Okay. Let's see. You want a 5 to 4, right? So if you 3, 3, that works. Because this side is length of 4. If you add them up, it's more than 4. And then 2, 2, 2, 2. That's multiple 5. That is 5 to 4. So I know this is 10 to 12. Or that's 5 to... No, we can't be doing that. So then it would be... Wait, you know what? I could just think of it like 5 to 4, 10 to 8. Can A be made with 3s? It can't. Double again. Times 3, 15 to 12. Can we do that? We can. So, and this will require, wait, this 2 by 3. This 2 side. Oh no, oh yeah, wait, the 3 side you'll need 5 of them, times 5. And the 2 side you need 6. And 6 times 5 is 30. So it's D. Sorry, my bad, I'm not putting all the working out just because, why am I looking at the, working out, you get me? Because, time limit. So it's 30. But I keep forgetting to, so. 3 dice, each showing numbers 1 to 6, are colored red, blue, and yellow. Each of the dice is rolled once. The total of the numbers rolled is 10. And how many different ways can it sound? I hate probability, or like just these weird questions. Wait, showing numbers 1 to 6 are colored red and blue and yellow. Each of the dice is rolled once. Total of numbers rolled is 10. How many different? Yeah, I'll be sorry, I just don't know how to answer. I can do like all like wordy like number questions, but when it comes to words questions, that's my drawback. An array of 25 equally spaced dots is drawn in a square grid. Pointer is the left bottom corner. Linda wants to draw a straight line through the diagram, which passes through O and exactly one other point. How many such lines can... So she wants it to... Wait, what? Draw a straight line through the diagram. Who makes these questions? I'll be... What? Why does Linda want a straight line through it? Like, anyways. So I'm guessing that's the solution. Okay, what is that? That's the solution. So, through the triangle was passed through and exactly one of a point. So, I'm guessing it can also come from other points. Like, for example, but it says through the diagram. Okay, wait. Also here. And this one too. Yep, that one also. That one also. Now, I mean, I have 4, but I feel like, why is there 6, 8, 12, and 24? maybe, nah, the other points don't really, what? Oh, that could work, you know. I know how to, okay, 1, 2, 3, there's symmetry, so I can 3 times 2. You know what, I'm just gonna go with B. I know I can lose a point if I get wrong, but I feel like that's the reasonable answer. I mean, why would there be 8? Like, I can't even see that many options. I feel like it should be B. 17. And also, I might often see if I would have gone gold if did this. Alright. A circle of radius R and a right angled isosceles triangle are drawn such that one of the short sides of the triangle is the diameter of the circle. So basically all it's saying is we have this circle. Sorry, I'm drawing on like a lifted tablet, so it's really weird to do this. So the radiuses are, okay, let me just remember that. Maybe put a center here, that's R. I'm also going to do that, so it's good to draw things. Draw such one of short side. What is the shade area? So I know this is, wait, sorry, it looks bad in the diagram, but maybe this looks better. That's clearly a right angle. So the area of this sector would be 1/4 pi r squared. So pi r squared over 4. And then, because we're trying to find the shaded, right? So we have to minus it by the area of the triangle, which is r squared over 2. Now, this is 2r squared over 4. So it's equal to pi r squared minus 2r squared over 4. Now this is for, it's called mini shaded. Now to find the other one, I am noticing, oh, this isn't a kite. I could take the area, right? I could take, so see this really big triangle. Okay, let me just delete that. That's, well, you saw it now. Really big triangle. Minus that by these 2 parts, and you get the area of it, right? So the area of this part was, let's just formulate an equation. Here's gonna be the area of big triangle, which, well, it told me it's a right angled isosceles triangle. So if this R, this is 2R. That's also me 2R. Just using information. So 2R times 2R over 2. So that's going to be 4r squared over 2 is 2r squared. Right? Yeah. So I can just simplify now. 2r squared minus the area of this part is going to be pi r squared over 4. Plus the area of in a triangle, which was just 2r squared over 4. Okay, this is very long. What's the shade area? Okay, so I feel like the answer is going to be like 2 pi r. Okay, let's just do 2r squared minus, so that's going to be pi r squared plus 2r squared over 4. Now I do know that this whole thing is going to be added to pi r squared minus 2r squared over 4. 2r squared plus pi r squared minus 2r squared minus pi r squared minus 2r squared all over 4. Simplify this, 2r squared plus, these cancel, we're just left with minus 4r squared over 4. So 2r squared minus r squared, and that should, that looks reasonable to me. It's very weird that that area is r squared. Like, yeah, it's all these unit circles. They have such weird answers. All right, okay, final page. You know what? Half an hour, I've done 17 questions. I haven't even gone that. How am I doing better when recording than? Okay, that's just, yeah, I got no clue. Okay, 18. Oh, factorial question. We love putting those in. Sorry. The number 840 can be written as p factorial over q factorial positive integers. Okay, p and q are less than 10. What's the value of p plus q? So I think, so if p factorial or q factorial is equal to 840, I think we're probably going to look at factors. So things are going to cancel out on p factorial. Like things in q will cancel out things in p. And that just left us with 840. So 840 is, okay, let me just write it down as, let me just do it like this. So we have 10 and 84. That's 2 and 42. That's 7 and 6. That's 2 and 3. That's 5 and 2. So it's equal to, wait, 2, 1, 2. Oh, wait, let me just circle everything that I need. So that's me 2 cubed times 5 times 3. Okay. So let me think about this. I feel like, let me look at the answers. Okay, first of all, it's not C. Okay. Or you know what, actually it could be 8 factorial, 2 factorial. Yeah, that would make sense. Or 5. Okay, I think I just have to do some guessing. I believe this is saying we had some number here that maybe it was like, let me see what's missing. So if I rewrite this, 2 times 3 times 4 times 5 times, or to be fair, the 4 could have, wait, sorry, 2 times 3 times 4, if I replace that, 2 times 3 times 4 times 5, that is what's missing. So if that's what's missing, then wasn't this 5 factorial? Six times 5. Wait, 840 is equal to 5 factorial. Wait, is that right? 5 factorial is 5 times 4 times 3 times 2. 20 times 40 times 1. Okay, what am I talking about? That's right though. 840 equals 2 squared is 4. 2 times 3 times 4 times 5. I feel like I've done something wrong. Oh, the 7. Oh my days. Bro, I thought that was 76. Okay, there we go. So 7 times, and then 6. Just don't know what happened there. So the number on top, what's right? Is it even 12 and 15? Okay. The number of top, don't worry, I know I'm taking very long, but these are last questions. People don't usually even answer these, but just see what happens. So basically, what I'm trying to say is, I'm trying to see what's missing. Okay, so this whole number, we have 5 factorial and it's just times 7. So I'm guessing, was it 6 factorial on top? The thing is that the 6 is missing. What is it? 6, 5, 4. 7 times 6 times 5. Should I go on with this? I feel like I'm getting close though. Wait. Let me just guess this. Suppose it was like, I don't know, I'm just guessing, yeah. Maybe it's like 8 factorial on top, right? You see, what's troubling me, right, is, for example, 8 can be written as 2 times 4. So my whole thing would be rubbish. Well, to be fair, it could. 2 times this, so 2 times 2 times 5 times 3 times 2 times 7. This could be 4 times 6 times 5 times 7, which means it can't be 8 and 3 because the sum wouldn't be, it's non-answer. Is it that? We don't have an 8, do we? 4 times, no wait, 4, 2 times 2 is 4, 4 times 2 is 8. So we'll have 8 times 3 times 5 times 7. What if it was 8 times 7 times 5 times 6, but the 2 has disappeared? So it's 8 factorial, 2 factorial. Wait, 8 times 7 times... What? 8 came to me the second I looked at this question, and for some reason it's looking like an answer. Wait. Times 3 times 2 over 2. Oh, maybe not. No, that wouldn't work. Because 8, 7, 6, 5, 4, 3. Where's my 4 and 3 gone? Disappeared. Oh, wait, well, this could be 8 times 7 times 2 times 3 times 5. 2, 3, and 5. That's not a number that we know. 20. What is that? Anything we know? 4 times 3 times 2. 3 times 2. No. Do I take the risk and answer this? You know, I'll spend like 1 minute on this and I'm cutting. Okay, it's not 8 factorial, 2 factorial. But I have confirmed this is equal to 840. 30 times 56. That doesn't make sense. How's that equal to? Is this right? 7 times 2 times 2 times 2 times 3 times 5, which is 7 times 8 times 3 times 5. Where did the extra 2 come? Okay, I don't know what happened there. Or this could be 2 times 3 times 4 times 5 times 7. Only thing here missing is a 6. Wait, this is the answer. Wait, 7 times 6 times 5 times 4 times 3 times 2. Okay, I got bad time. I don't make this video long. Sorry, I'm not that good at editing. Over 3 times 2. These cancel out. And then this part is 2 times 3, which is the part. So the answer is 10. 7 plus 3. Oh, W. Okay, what's this next one? Diagram shows 2 overlapping triangles. Triangle FGH. With the triangle 60, 30, 90. So, wait, FGH. Okay, so I'm guessing that's 60 and that's 30. Okay, I get it. Triangle EGH. Triangle. What's the ratio of the area of the triangle IFG? Yeah, this is long. Okay, what is going on? I mean, I suppose I could do some stuff. Draw out. So at first, this is looking pretty dead. I don't even like these type of questions too. So I'm guessing we have to label side X maybe. Because if we want area, then we need some sides, but there's literally nothing. We do know that EGH is right angled isosceles. Maybe that would. So IFG and IEH both share a common side, and that's this. I'm just going to label that X. IGH, anything you know about that? Like angles? So we know FGH has certain angles. So this one's 30 degrees. And then this whole thing is 60 degrees. So yeah, we have to work some things out. So I'm trying to... There's really nothing we can do here. I don't think so. Wait. Area triangle IFG. What would we need for the area? I feel like if only you could find like maybe these angles. I don't know. Or could we? Wait, if that's 30, and this whole thing is 60. What are the end of the triangle? Is there anything we know about that? I don't see anything about that. This is a hard one, can't I? Maybe similar triangles? Nah, how do you even get started with this? I do know that there's one side sharing. Maybe make this into a triangle? Does that even help? Nah, that doesn't even help. Oh, wait, what does it? I mean, those are right angles, but there's literally nothing we can do. Yeah, skipping this. Just no idea what's going on there. And I keep forgetting to do this. 20. Laura and Dina are having a running race. Laura runs at constant speed. Dina runs n times as fast. Laura's estimates. What this? Whoa. They all I know is N. S has come out of nowhere. Oh, and never mind, estimates. Laura runs at constant. Okay, I think maybe something has to equate here. So we're looking for an M, because it says what distance in meters. Let's see, speed equals distance over time, right? So for Laura, speed equals distance over time. When you look at Dina, wait, speed equals M over T. And then for Dina, it does tell me she runs n times as fast, so ns equals m over t. There's one thing that's missing though, and that's the Laura starts s meters in front of Dina. Now if we're equating for m, Laura starts s meters in front of Dina. Wait, if that, so when they overtake, let's say when they meet, yeah, it's going to be certain distance. Surely it's going to become m minus s for m minus. Oh, this looks really confusing because there's another s on my finger. Okay, maybe speed. Is there another thing I can use for that? Not really. So wait, I do know s equals m over nt, just equating. So m over t equals m over nt. Now, the times disappear, they do. I think one of them has Dina run before she overtakes Laura. I feel like it's going to be m minus s maybe for Dina. Or for Laura. If she starts s meters in front, you know, I'm just going to do m minus s here. So then when we equate them, s equals m over t. Okay, this is m minus s over t. Nt m minus s equals mt. T m minus s equals t. Tm minus st equals t. That makes no sense. How comes the t's have... Or maybe it's the time. Maybe we're equating for time. Let's check. S, so we do know s equals m over, and I'm trying to get formulas out of this. If you equate for time, then m minus s over s. Okay, this looks so bad. What's n again? N times as fast. See, this problem. Why did they put s meters in front when people use speed for distance over time? Okay. M minus s over, well, s. Okay, that looks really bad. M over NT. I think I'm just going to use C for this thing. C. N NT M minus C equals MS. But this is speed, okay? That's the starting distance. And MTN minus CNT equals MS. And also for again MTN minus MS is equal to add CNT on the other side. S minus TN equals CNT, and M equals CNT over S minus TN. Please start for S. I'm gonna do it again. I can't film this one. I feel like I'm getting close to it, but just restart. This is the thing I like to. You know, people like check over their work. I literally just delete everything. Oh, I'm not gonna lie. Wait. So law runs at constant speed. So it just tells us speed equals distance over time. What and Dina runs n times this. Wait. Think about it. If for the Dina, if ns equals m over t, m over t, s equals m over nt, the speeds are the same, so you can actually make them equal to each other. Okay, that's good. So s equals m over nt. Now it does tell us Laura starts s meters in front of Tina. So then wouldn't this one have to be m minus s? M minus s would bring us to the starting point. So this whole thing is literally the same. And then we can solve. Okay, let me try this. So s equals m over nt. M minus s over t equals m over nt. T's cancel. You can times t both sides. M minus s equals m over n. Nm minus Sn equals m. Nm minus m equals ns. Wait, I'm doing it. M equals ns over n minus 1. That's it. That's a W. Come on. Oh, there we go. Okay, somehow I got better doing it second time. Then I don't know how that works. Okay, what's going on here? The numbers m and k satisfy the equation. So we have, okay, we can write down 2 to the power of m plus 2 to the power of k equals p. 2 to the power of m minus 2 to the power of k is equal to q. What is the value of 2 to the power of m plus k in terms of p and q? If I add both equations, so a lot of things like cancel out. If I add them both, we can have, so if I bring this like down and you add them, the 2 to the power of k minus 2 to the power of k will cancel out. So you get 2 to the power of m, well now you have 2 lots, is equal to p plus k. That is not useful, because we're trying to look for 2 to the power of m plus k. There are some squares here, some squares. Okay, already it's not p plus k because I just found another expression for that. How is 2 to the power of 2m equal to 2 to the power of m plus k? It doesn't make sense. bk over 2. Okay, you know what? Maybe if I do this process, wait, if I square both sides, I can get 2 to the power of m plus k. Because first of all, let me just try to find that. If I, for this one, if I square both sides, okay, let me just, I can't do it in my head like this. P squared, right? 2 to the power 2, 2 to the power 2m plus 2 to the power m plus k Okay, so plus 2 lots of that, plus 2 power 2k equals p squared. Do it for the other one, 2 power m. Okay, now I think I can do some. We're gonna get 2 power 2m minus 2 lots of 2 power m plus k plus 2 power 2k equals q squared. Wait, but now I can minus. If I'm not mistaken, if I minus these ones will cancel out. These won't cancel out. These will cancel. That could work, you know. Wait, minus them now. You get 0. 2 minus 2 is plus 4 times 2 power m plus k. 2 power 2k minus itself is just 0. It was p squared minus q squared. So then 4 times 2 power m plus k equals p squared minus q squared. 2 power m plus k, p squared minus q squared. Wait, did I get that? I was, something's up with me. You know, these are supposed to be like the hard questions. Why am I getting, I've gone 3 of them already. To be fair, I could be wrong with some of them, but so far, I hope this is a gold level. So, I think you need like 90 points. I have no idea. Wait, I did it. Alright, next. 3-2. Triangle with interior angles 60 degrees, 45 and 75 is inscribed in a circle so radius 2. Okay, first let's draw a circle. I think that's the easier one. A triangle with interior angles 60 degrees, 45 degrees, 75 degrees. Okay. Let's draw a triangle here. This is 60 degrees. So we got 45 degrees. We got 75 degrees. Inscribed on a circle so radius 2. What is every triangle? I think so. Luckily, because of my prior knowledge, I think there's a way to do this. If I just use the brain cells, if I do this, this will be double this angle, so it's 120. This same process, and then this, and if you add them all up, it equals 360. And then these are actually the radius. Okay, I'm lucky because I've sort of seen this before, but I don't know from where. But I think there's a solution. And now you can just find the area of a triangle using half AB sine C. So half 2 times 2 times sine 120. Okay, if I add them all out, I can fact out this part. So it'll be 2 times, because AB is also, half AB is always the same. You just take out, and that's just 2. So sine 120 plus sine 150 plus sine 90. So sine 120 is sine 180 minus 60, which is just sine 60, which is root 3 over 2. Root 3 over 2 plus sine 150 is 180 minus 30, so sine 30, so it's a half, plus 1. Times 2 on everything should be root 3 plus 1 plus 2, which is 3 plus 3. I hope that's one of the answers. Yes, E. Okay, method worked. Oh wait, it's actually sick. I'm actually getting things right. Let x be a real number. What's the minimum value? Sorry, my neck. Let x be a real number. What's the minimum value of this whole thing? Minimum value is usually like derivative. Maybe. Maybe let me. Okay, I don't want to skip this because it looks like such a simple question, but okay, let me just try it. So we're gonna have x power 4 plus 4x cubed plus 3x squared minus 4x cubed minus 16x squared minus 12x plus 3x squared plus 12x plus 9. Okay, I'm guessing stuff should cancel out. 4x cubed, okay, these cancel. 3x squared, these cancel. These cancel. So x to 4 minus 16x squared plus 9. Now this is a hidden quadratic, u equals x squared. So u squared minus 16u plus 9. Now to find minimum value, so already I know this function is positive. It has a minimum. It has a minimum. If it was max, if it was like that, like my answer would be in this form. There's no minimum, so this looks good. So if we do the complete square, so keep going. So it's going to equal to u minus 5 by 2. Oh. U minus 2, wait, u minus 8 squared minus 16 squared, wait, what? Plus 9. No, that looks terrible. Wrong. Wait, I'm trying to figure out, am I doing this right? I've got u squared minus 16u plus 9. Okay, you know what, I'm just gonna take derivative. I don't know how to do that stuff. Okay, u equals 8. Put it back in. 8 squared minus 16 times 8 plus 9. 64 minus 16 times 8. I took derivative, made equal to 0, u equals 8. Put it back in. 64 minus 16 times 8. 104 plus 9. But isn't that like minus 31? That's none of the answers. Did I do this right? X 16x squared, where do I get that from? X of 4 plus 4x cubed plus 3x squared minus 4x cubed minus 16x squared. Okay. Oh wait. It's because I did that, didn't I? U equals x squared. Wait, so u squared minus 16u plus 9 equals 0. Okay, wait. Complete the square for this. U minus 8 square minus 64 plus blah blah. I'm only caring about this value. 8. You put u equals 8 equals x squared. So then x squared minus 16, 8 plus 9. No, that's still the same thing. I'm not getting any of these values. I know there's a minimum. Maybe I could just is that right? Minus 20. I do know it's 8. It's at the value of 8. Is the minimum value, but for some reason it's not giving me any of these answers. I feel like I've done something wrong. And this is exactly why you do it again. See guys, I am teaching failure, okay? This is where you start. I can't add. I don't know if I'm going to do other questions. You know what, I'm just going to do this. Okay, we have x squared minus 4x plus 3. X squared plus 4x plus 3. I can't lie, this is x plus 3 plus 1. X plus 1. That's x minus 3. X minus 1. So it's going to be x squared minus 9. X squared minus 1. And that's how you get x of 4 minus 10x squared. Wait. Or maybe it wasn't 16 before. I don't even know. Like, now I'm getting this. Minimum value of this would be u equal x squared. Let's do that thing again. Oh, you know, I don't even have to. X squared minus 10 squared minus 100 plus 9. Which is minus, Nope, no. X minus 5 squared. Minus 25 plus 9. X squared minus 5 squared minus 16. Minus 16, that's the answer. Oh my days. See guys, it's all about the failure, okay? I know it's a long video, probably not gonna watch this, but it's, if you ever do watch it, this is one life lesson you should learn. 24. Saba, Rain, and Darren are cooperating. Unlucky. Oh, it's been like an hour, damn. Cooperate to complete a task. Each work at constant rate. Okay, let me remember that. In power, whoever was working on the task. When all three work together, it takes 5 minutes to complete the task. When all three are working together, it takes 5 minutes to complete the task. When Sab is working with Darren, the task takes 7 minutes to complete. Wait, it said they each work at constant rate. So I'm guessing when all three work together, so S plus R plus D. I'm guessing it's going to be 6 minutes to complete a task. But I feel like that's not the formula. It won't be equal to 5. It takes 5 minutes to complete a task. So Saba's work with Darren, task takes 7 minutes to complete. When Ryan's work with Darren, it takes 15 minutes to complete. Yeah, I got no clue. Yeah, skip that. But I don't even know how to get, like, the ones before I knew how to get stars, but 25. Okay, what is that? 5 light segments of length. Okay, so 2, 2, 2, 1, 3. Connect 2 corners of a square as shown in the diagram. What's the shaded area? How do you even know how to do this? 2, 2. Oh, wait, you know what? There could be a way. Let me try. Okay, last one's the hardest one. Well, that's what I remember when I did this like a year ago. No, I don't think I even did this UKMT. I wasn't even, yeah, like the ones prior. 3, 2, 2, 2, 2. Okay, so this is complete. Oh my days, I took the whole thing. Okay, because I'm trying to make. If I get a line, wait, this is just an idea, but I could get a line like that. Could I even help? No clue. Because then this part would be also 2. So we are 2, 2. Wait, let me draw it. I don't know if I could help though. But you know what, let me try. Because then you have a triangle here, right? Do we know anything about that? Wait, this part was... Yeah, I'm bugging. This part was 1. This part's also 1. That's 1. And there's nothing else after that. Wait, if I get the area of this and that and just minus it by the whole thing, then we're calm. I think that's what we want to do. Because the area of this is just 4, and then this thing is just 3, and then you got some weird triangle. Is there anything I know about that? That's 1. This side length is, well, no clue. I guess if we could solve for that side length, that would be pretty nice, I can't lie. Wait, no, this isn't even 3. The whole thing is 3, but we have no clue. You know what? I could do an estimation. Let's just suppose, yeah. This use that as x, okay? Now, then this part would, that's x. Wait, no, can't even do it. This is 2, 2, 2, 1. This thing's 3. This whole thing is 4, right? This is also 2. 2 plus 2 is 4. This thing, you see how the answer is a whole number, right? So We might deal with fractions, but they'll cancel out. So I don't know, let's just see. Call this x maybe. Maybe 3 minus x. No, that wouldn't work. Oh. If that's 4. You know what, just look at the diagram here. This part would probably be like 2.7. You know what, if that's 2, this whole thing is 6. So then, what about this thing? That'll probably be like 7. If that's 7, then 7 equals area of a square, so 2x squared, 7 wait, 7 squared equals x squared plus x squared, 49 over 2. Now, you know what, let me use a nice number. Okay, 8. If that's 8, 4 equals x squared, x equals 2. Wait, does that work? 2 squared plus 2 squared. That's root 8. What am I on about? Alright, wait. 64. So 8 equals 2x squared. 64 equals 2x squared. 2 equals x squared. Square root of 32 is 2 root 5 equals x. So it's 2 root 5. That's 2 root 5. Now this is less than half the area of a square. If the area of a square is 2 root 5 squared, which we just said was 32, less than 32 is less than 16. We have this 4, right? So it's going to be 12. But we have this bit here. Now that looks solve the area of the square, which is 4. So I would guess it's either 8 or 9. I feel like 9 is like some irregular number. So you know, I'll go for it. Go for B. Right. Give me 1 second. Right, guys. Magically, the answers appeared. Who knows how? But yeah, I'm just gonna mark them really. See what I get. Okay, number 1, C, perfect. Number 2, C. Let's go. I was right. Wait, 37, 41, 43. There you go. And you see, that's exactly what I talked about. Well, it's so cool. Here's black pen, there's green pen. Okay, no one cares. 3C, let's go. 4D, let's go. 5E, let's go. 6B, yes, exactly what I talked about. Whoa, why is there so much wording? 7, yes, B. Alright, 7 in a row, let's go. 8B. Oh, I forgot I was. Yeah, anyways, I remember what answers I put, anyways. I literally forgot. I put the answers to the worksheet, now I need them on here. I love me. 9D. Did I even do it right? No clue, but I got the answer. I'll take it. 10E. Ooh, 10D. The answer was 90. Wait, no. Wait, no, I remember I changed the answer to 90. Okay, I got it right. Okay. I remember I put 90. It's just the answers I put on the worksheet. Okay, I just need to remember answers, I'm not gonna lie. 11. Option E provides, yep, 119. Okay, I got this right. 12. What 5 possible values? 7, 15. Wait, no, wait. 105 was included. Even though 1 was not. Fair enough. Alright, guys. We always learn from failure. Okay? That's the first step to greatness. Okay. 12, 8, 13. Where's 13? 13D? Yes. That one took very long for some reason. 14D. Wait, I got it. Woo! W. Wait, so far I've got like 13, 12 right. Wait, this is sick. 15 we didn't do it. Well, let's see the answer anyways. Yeah, don't even know what that's talking about. 16C, or I got B. Overlay 25. Okay, yeah, that were my points apparently. Fair enough. Okay, how about doing these 20 points? I'm trying for gold. 17B. Did I get it? Whoo! R squared. See it right there. Let's go. 18. I swear if I got this right. Oh my goodness. 7 factorial and 3 factorial. After perseverance. What am I talking about? Perseverance. I got it. Yeah, I don't know what that 19 was talking about. Yeah, no idea. I swear if I get 20 right. Oh my goodness, it was A. It was A. I got it. What the hell? Now 21. Oh my goodness, I even got this. I'm the GOAT. What? No, wait, 22. Look how much they did for this. Why did they do that? Literally, look at my method. It was literally just like 3 steps. They did the whole calculation and everything. A whole like, explanation. Oh my god, I even got this. 3 plus root 3. That's not. 22. Oh my goodness, it was minus 16. Perseverance. 25. If I get this, I'm just gonna. Oh my goodness. Literally, it's all about the brain cells. You need to utilize them correctly. Look, I just did estimates and I got them. Wait. No, I need to calculate this real quick. Alright, 1. Okay, basically how it works is you start 25 points, and then I think you need like 90 for gold. I'm just gonna see how I get. And then you minus how many you got wrong, and whatever you get right, you times by 4, and that's your mark. So 25 plus 4 times. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Wait. I did this on camera. 24, 20. And then 1, 2. Wait, what? That's 103. Wait, I swear you can get it. You can get into the Olympiad with that. Now I need to check. Wait a minute. Alright guys, I'll be done real soon. See math challenge, passed. Oh wait, grade boundaries. And this is the 2021 paper. Ah, 108 for Olympiad. But 85 for kangaroo. And you know, I did this enough. I even did this with 15 minutes to spare. Or 20 minutes to spare. Alright guys, thanks for watching, yeah? Hope just use this as an education video just to see how smart people think. Okay, I don't want to call myself smart because I'm dumb in other ways. But maths is a strong point, okay? So yeah, thanks for watching guys. Hope you guys smash all your exams and see you next one.